In this question, we've been given a table that summarizes the university responses to applicants. They were either given an offer or not given an offer, and we have whether they came from a state school, grammar school, or private school. We've been asked to use a chi-squared test at a 10% level of significance to investigate if there's any association between the type of school the applicant attends and the response from this university. We're going to start with our hypotheses. This is a contingency table. We're testing for association. We're testing for independence. So we're going to use that terminology. The questions already mentioned association, so I'll go with that form. Null hypothesis. There is no association between the type of school and the university response. Alternate hypothesis. There is an association between the type of school and the university response. First, we want to generate some expected values. We can do that if we have row totals and column totals. So I'll just do some addition here and add these on. In both directions, we get a grand total of 200. To calculate the expected value for any cell, we're going to calculate the row total by the column total and divide by the grand total of 200. So the expected frequency of students from state schools who get an offer, we're going to calculate that by doing 36 times 84 divided by 200. And that gets you 16.02. We'll do a similar thing for each of these cells and we'll get all of our expected frequencies. And we'll just do a check here to make sure that none of these are smaller than 5 and they all are valid expected frequencies. We can get on with the hypothesis test. We've been asked to do a 10% level of significance. Our degrees of freedom is going to be 2 times 1, 2 degrees of freedom. Our chi-squared critical value is going to come from the tables. At a 10% level of significance with 2 degrees of freedom, that critical value is 4.605. Any test statistic larger than this, any test statistic in the shaded region is going to be a significant result. Let's find our test statistic. First, I'm going to summarize the observed and the expecteds in this table, and we have 6 pairs to work with. From there, we can calculate the test statistic. I'm going to use the sum of the observed squared over the expected minus n. So that's going to give us fractions. For each of these fractions is the black observed value squared divided by the red expected frequency. So I'll do this for all 6 pairs, and at the end we're going to subtract the n value, which in this case is going to be 200. Following that calculation all the way through, we get an answer of 2.505. That is our test statistic. Is it significant? It's over here on the left-hand side. It's not in the critical region. It's not a significant result. So let's just formalize that with the comparison. 2.505 is less than our critical value. This is not significant. That means that in our 2-part conclusion, we can say there is not enough evidence to reject H0. And in context, we can say there is not enough evidence of an association, of a link between the type of school an applicant attends and the university's response.